Hi there, I'm Gabe Hollenby, a Senior Developer Advocate here at Amazon Web Services. And if you're just getting started on AWS and you're trying to decide on a strategy for deploying your first web application, you're in the right place. In this session, I'll cover 3 great choices for deploying your web apps onto the AWS cloud. First, we'll examine the best option for deploying static website content and front-end apps. Then, we'll cover 2 popular approaches for cases where you have back-end code you'd like to manage too. For cases where you want full control over your environment in an easy-to-get-started fashion, we'll talk about running your own virtual private server. Then, we'll look at another service to help when you want a more managed experience where AWS will take care of operating system patching, deployment uptime, scalability, and more. First, let's talk about hosting static websites and front-end web apps. If you're building a single-page web app, then when it comes to delivering your front end to users, you just need a way to deploy and host a set of static HTML, CSS, and JavaScript files. Or maybe you're using a static website generator. For these cases, I recommend the AWS Amplify Console service. AWS Amplify Console is a static web hosting service that accelerates your application release cycle by providing a simple CI/CD workflow for building and deploying static web applications. Simply connect your application's code repository in the console, and changes to your front end and back end are deployed in a single workflow on every code commit. With the AWS Amplify Console, you can deploy single-page apps, SPAs, built with frameworks like React, Angular, Vue, and Ember, and static sites generated with frameworks like Gatsby, Eleventy, Hugo, ViewPress, and Jekyll. You can also host simple static websites without connecting to a Git provider just by performing a drag-and-drop deploy, selecting a folder from your desktop, or by referencing an Amazon S3 bucket or an external URL. The Amplify Console also works great alongside other AWS Amplify tooling that makes it really easy to provision, configure, and connect back-end resources like API servers and databases to your serverless web apps. Let's look at a few of Amplify Console's features. One of my favorite features of the Amplify Console is how it makes it really effortless to set up a continuous integration and continuous delivery pipeline. To get started, you just connect the Amplify Console to your Git repository, which could be in GitHub, or Bitbucket, or GitLab, or Amazon Code Commit. Then, the Amplify Console will automatically watch for any changes to whichever branches you elect to monitor. Whenever a change is detected, it will automatically provision a new environment for your app, build your app, and run any automated tests you've included in your repository. Deploy your updated app version if all your tests pass, and then verify that deployment has succeeded. Each new deployment is also executed in a completely atomic fashion, ensuring that everything needed to host your new app version will be deployed successfully before it begins to deliver this content to your users. It also performs instant cache invalidation as part of your deployments, ensuring that the content delivery network is not serving old cache content that was changed by your latest deploy. Finally, if you follow a development workflow where you create feature branches for your work, you'll be pleased to know that the Amplify Console has you covered here too. You can manually connect as many different branches as you like, and the Amplify Console will monitor and deploy each of those branches independently. But you can also configure a pattern-based feature branch deployment setup so that the system will automatically deploy new branches that match your desired pattern. Perhaps any branch prefixed with release dash, for example. AWS Amplify Console sets you up with global, scalable hosting. Your app is distributed to and hosted from AWS's massive content delivery network with over 200 points of presence all around the globe. This means that when users load your website or app, their browser will automatically fetch the content from a server that's geographically close to them, resulting in a faster load time and better user experience. By default, your app is served via an automatically generated domain, but the Amplify Console also makes it very easy to set up hosting from your own custom domain, and it will even help you generate and use free HTTPS certificate for your secure content delivery. And speaking of security, you also have the option of protecting your app with a simple username and password authentication flow, which is a great option if you're deploying multiple feature branches of your app and you want to protect some of those deployments from unauthenticated users. Well, getting started with the Amplify Console is really easy. You just connect your repository and review the auto-detected build settings, and make any necessary changes, then your first app version gets deployed. Let's take a look at a short demo to see this in action. We'll start from the home page of the AWS Management Console. From here, I'll just search for Amplify and select the service from the search results. Next, I'll click on the Get Started button in the Deploy section. Here, I just need to connect to my Git repository. In this case, I'll choose a repository on GitHub. When I click to continue, I'll just need to authorize the Amplify console to be able to access this repo on GitHub. Once that's done, I just select a branch to monitor and deploy. I'll choose Master. Finally, I just review the build settings and click Save and Deploy. Then my new build starts. You can see the process transition from provision to build to deploy to verify. I've sped up the recording here in the interest of time. In total, this deployment took just a few minutes. When the deploy's done, I can click on the deployment URL to view my app. In this case, I'm just showing off a simple web app that shows a product picker, letting the user view the details about various food items. So now that my app is deployed, let's make a small change and watch the whole process complete again automatically. First, I'll clone my repository to my workstation. Then, I'll open my editor and make a simple change to the app. Now my header on the page should say, "Compare these great products." I'll commit this change to Git and push the commit to my remote repository. Now let's go back to the Amplify console to see the status of my app. Here, you can see that it's already detected my new app version and started a new build. I'll click in to see the details, and we can watch as the build finishes. Now let's look at the app again, and after a refresh in my browser, we see my changes deployed live. It's just that simple. So, that was the Amplify console, a great place to host your static web content. But what about cases where you want a full server to host your apps? You might have your own PHP, Ruby, or Node.js app, for example. Or you might want a way to easily stand up a new server with existing open source software like WordPress, Magento, Drupal, or more. For simple variants of these cases, the best place for you to start could be with your own virtual private server in the cloud. And the easiest way to get started running your own virtual server in the cloud is with Amazon Lightsail. Lightsail is an easy-to-use cloud platform that offers you everything needed to build an application or website, plus the service is delivered via a cost-effective monthly plan. Whether you're new to the cloud or looking to get on the cloud quickly with AWS infrastructure you can trust, we've got you covered. Lightsail is ideal for simpler workloads, quick deployments, and getting started on AWS. It's designed to help you start small and scale as you grow. Getting started with Lightsail is really easy. It comes with its own separate web console that's a lot simpler than the rest of the AWS console. It's very helpful because it was built to show you all of your Lightsail resources in one place with meaningful defaults for launching new servers. Every Lightsail plan includes a server with a static IP address, secure networking, built-in DNS management, one-click SSH terminal access for Linux or Unix systems, one-click remote desktop access for Windows servers, highly available SSD storage, server monitoring, and more. Lightsail also comes with a very simple billing model, giving you low, predictable pricing. When you create a Lightsail virtual server, it's easy to see how much you're going to pay each month. Managing your resources in Lightsail is not only easy, thanks to the simple web console, but it's flexible too. Every action you can do in the web console can also be done by making API calls to the Lightsail service. Finally, it's also easy to grow with Lightsail. Besides offering virtual servers, Lightsail also lets you create fully managed databases and load balancers with fixed pricing. And if you get to the point where you want to bring your resources out into the wider AWS ecosystem, Lightsail makes it easy to snapshot and export your virtual machines onto AWS's Elastic Compute Cloud, or EC2 as we often call it, which allows you to provision virtual machines with more fine-grained control over compute, memory, and storage capabilities. Of course, if you're already a bit familiar with AWS, you may know about Amazon EC2, which also allows you to run virtual machines on the AWS cloud. So the question you might be asking is, when should I use Lightsail and when is it more appropriate to use EC2? Lightsail is best suited for small-scale generic apps, websites, or web applications, where you might only need one or just a handful of servers to deliver your app. It's also a great choice if you're looking for a low-cost virtual server with a generous amount of included outbound network data transfer included right in the pricing. EC2 is a better choice if you need to provision large, complex environments with dozens of virtual machines, or for any cases where you have workloads with advanced networking needs or ones that require specifically optimized virtual machines, things like big data analytics or high performance or scientific computing. For a lot of use cases, Lightsail's simplicity and affordability are the right choice to get the job done. Lightsail makes it easy to deploy a web application with just a few clicks. With pre-configured development stacks like LAMP, Nginx, Mean, and Node.js, we make it easy to get a server created to host your web application quickly. You can also use Lightsail to quickly create a website that shines. Create and customize a blog, e-commerce, or personal website with Lightsail's pre-configured applications like WordPress, Magento, Plesk, and Joomla. Or easily run open source and commercial software for your business. Lightsail helps you quickly launch your line of business software like file sharing and storage, backups, financial and accounting software, and much more. So, one great feature about Lightsail that I want to stress is how easy it is to get popular operating systems and applications installed on your own private server. Lightsail offers a large number of pre-configured, one-click-to-launch application or developer stacks, including WordPress, Plesk, LAMP, and Node.js, and more, and operating systems including Amazon Linux, Windows Server, Ubuntu, CentOS, and more. For example, if you want to get your own private WordPress server or LAMP stack up and running on AWS, I can't think of a faster way than using Lightsail. And speaking of LAMP stacks, the combination of Linux, Apache, MySQL, and PHP, I want to show you a demo of just how quick and easy it is to get a simple LAMP stack application deployed on Lightsail. I'll start here at the Amazon Lightsail web console, where I'm already logged in. You can see that I'm looking at the instances section of the console, and there's a big Create Instance button. So let's click that to get started. Next, I can choose the AWS region where my virtual server instance will reside. We have regions all over the world, but in this case, I'll choose to place the server in AWS's Oregon region in the United States. I also get to select the operating system that I want to run on. Since I want to deploy a LAMP stack, I'll choose the Linux Unix platform and then select the LAMP PHP 7 blueprint. I could choose to go with a blueprint that only installs the OS, but by picking the LAMP blueprint, I'll get a server set up with PHP, Apache, and MySQL. All I'll need to do is add my code to the server. Next, I'm going to paste in a simple launch script here to add my code. This is a set of commands that will only run once when the server is first initialized. And what it does is it starts off by deleting the default website, because by default, the LAMP stack blueprint includes a default website managed by Apache. We're going to delete that so we can have our own website. Then we'll use Git to clone the application out of our Git repo. Then there's a special connection values file that we'll set appropriate ownership on. And we'll copy the password into our configuration file and create our MySQL database using that password to connect to MySQL running on the server. This is a pretty standard installation script. It's the same sort of script you'd run on a virtual machine or a physical server. It's just the set of steps we're doing to install our application in a scripted fashion. Next, I'll set my server to backup automatically, and I'll select the desired time of day when I want the backups to occur. Next, I'll pick an instance size. Here, I'll pick the $5 instance. The price of the instance governs the amount of CPU, RAM, disk space, and data transfer that's included. Then I'll name my instance, and since I'm going to be deploying a simple to-do application, I'll name my server to-do. And the last thing I can do, if I want, is to optionally tag my instance. I'll add a tag that identifies this server as the one where I'm running my to-do application. Then I'll click Create Instance and wait just a moment for the server to get created with my application code running on it. So the server is now running. I can see its status there under its name, and I can copy the public IP address of the instance and then go to that in my web browser. So here's my simple to-do PHP app running. And if we look at these values that my app prints out, you can see that the front-end host is showing the local IP address of the web server, and the database host says localhost because in this case, the database server and the app server are on the same machine. MySQL is running alongside Apache and the PHP engine here on the same Lightsail instance. And that's it. As you can see, it's really easy to get started, and you can be up and running in only a few minutes. Of course, sometimes we want more than a simple virtual private server. After all, when you have your own server, you're responsible for keeping the operating system and software services running on it patched and up to date. What if you want a more managed solution instead? For this case, we have AWS Elastic Beanstalk. Named after the magical beanstalk in the fairy tale that took Jack to the giant's castle in the cloud, Elastic Beanstalk is a great way to take your own applications to the cloud while having AWS manage much of the complexity for you. Oftentimes, you start out with a web app that you know you want to deploy, and deploying is one thing. But how do you also design for high availability and dynamic scaling and safe version deployments? How do you keep your application runtime updated and your operating system patched? How do you monitor your application health? Of course, AWS provides lots of building blocks that allow you to build virtually anything. And this amount of choice is great, but many customers asked us, isn't there just one service I can learn and use to host my web applications? And the answer is yes. It's AWS Elastic Beanstalk. Elastic Beanstalk is our easy-to-use service for deploying and scaling web applications and services, developed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on familiar servers such as Apache, Nginx, Passenger, and IIS. You can simply upload your code, and Elastic Beanstalk automatically handles the deployment, including capacity provisioning, load balancing, auto-scaling, and application health monitoring. At the same time, you retain full control over the AWS resources powering your application and can access the underlying resources at any time. There's no additional charge for Elastic Beanstalk. You only pay for the AWS resources needed to store and run your applications. Elastic Beanstalk provisions and operates the infrastructure and manages the application platform for you. So, you don't have to spend the time or develop the expertise to do the operations work yourself. It will also keep the underlying platform running your application up to date with the latest patches and updates. This means you get to focus on writing code rather than spending time managing and configuring servers, databases, load balancers, firewalls, and networks. We support many popular language runtimes, and you can even bring your own Docker containers if you've already done the work to containerize your app with its runtime dependencies. Besides the application runtime itself, Elastic Beanstalk manages quite a few other components as well. Starting with the EC2 host, Elastic Beanstalk manages the host operating system, along with the application server and the language interpreter used to run your web app. It also takes care of the HTTP server itself on the host, and it puts your code in the right place so that everything works in harmony together to serve your application properly. If you were to set this all up yourself on a server you managed, you'd have to make the initial decisions about all these components, and you would be responsible for keeping them all up to date. Instead, Elastic Beanstalk provides a set of curated platforms for your application to run on, ensuring that all these components are working seamlessly together. And Elastic Beanstalk can automatically update and patch these components during a periodic maintenance window that you select, reducing your operational overhead. All of this means that as builders, you get to spend more time building. In fact, here are a few facts and quotes from some customers about their experiences using Elastic Beanstalk. So getting started with Elastic Beanstalk is easy. First, you create an application environment containing some information about the kind of application you want to deploy and the configuration of load balancing, databases, and more. Then, you pass your application to Elastic Beanstalk and it handles deploying it to your servers. Finally, Elastic Beanstalk monitors your application environment and takes care of availability, scalability, and security. Let's see a short demo of this in action. We'll deploy the same LAMP Stack to-do app that we used before for the Lightsail demo, but this time on Elastic Beanstalk. I'll start here at the Elastic Beanstalk homepage inside the AWS Management Console. I'll click Create Application. Then I'll give my application a name. I'll tag it, and I'll select PHP as the platform, since this is a LAMP app. Next, I'll upload a zip file of my to-do app source code from my workstation and click to configure a few more options. First, I'll switch to the high availability preset because I like the idea of having multiple sets of my application distributed behind a load balancer. Then I'll scroll down and click to add a database to this application. I'll pick MySQL since this is a LAMP app, and I'll choose the database username and password. I'll also select the high availability option here so that I get a primary database and a secondary failover in a separate availability zone as well. Finally, I'll click Create App and wait a few minutes while Elastic Beanstalk takes care of setting up my load-balanced, high-availability app and database servers for me. Oh, and it'll deploy my code to the servers too. As you can see, it takes some time, but we can follow along in the console to watch its progress. When it's all done, we get a version of the app deployed. But you'll notice that we have a health warning. This is because our app isn't fully initialized yet. All we did was deploy the app code, but we haven't initialized the database yet. Still, I can click the URL shown to view my web app in a new browser tab. For this simple to-dos app, I have an install.php file that we can run once to take care of creating the database tables that the app needs. So let's visit that URL one time, then check on the app again. There, it's working now. And I can create and edit a new to-do to show that the data is persisting correctly to the database. Finally, if we go back to our application's dashboard in Elastic Beanstalk, we can see the health of our app changes to OK now that our database has been initialized and the app is working properly. That's it. So, in that last demo, you saw the initial deployment of our app. But what about your subsequent deployments, once users are already using the app? It turns out there are a number of deployment strategies built into Elastic Beanstalk, and you can select the option that strikes the right balance for your specific needs. I won't read all of them out here, but for example, you can elect for an all-at-once deployment, which is really fast, but it could result in a small amount of downtime for some users. Or you could elect for a much slower immutable deployment option that spins up new virtual machines for each deployment. While taking more time to roll out, this approach has the advantage of making rollbacks quick and safe, since the machines hosting the previous version of your app were not touched at all during the deployment of the new version. And speaking of rollbacks, I should also take a moment to talk about Elastic Beanstalk's built-in health monitoring. When you're running a production website, it's important to know that your application is available and responding to requests. To assist with monitoring your application's responsiveness, Elastic Beanstalk provides features that monitor statistics about your application and create alerts that trigger when thresholds are exceeded. Here's a screenshot of an application environment health dashboard on Elastic Beanstalk. As you can see, you get a nice collection of metrics, graphs, and alerts, all set up for you automatically. You also get automatic platform upgrades. As I mentioned, Elastic Beanstalk will provide you with regular platform updates that reflect patches to the operating system and runtime components. This feature is enabled by default, and all you need to do is specify a maintenance window when you are okay with having your instances patched and updated. I strongly recommend that you keep this managed updates feature enabled, as it's one of the ways you'll know that your systems are kept up to date without having to worry about it yourself. Lastly, I just want to quickly point out that we also have a really helpful Elastic Beanstalk command line tool. If you're like me and you often live in your terminal's command line, you should definitely check out the Elastic Beanstalk CLI. It has a number of built-in commands to help you do everything from creating and deploying application environments, to monitoring the health of your applications, to scaling your apps, accessing your application logs, and more. And that concludes my short tour of 3 of our best services to help you run your web apps in the cloud. We looked at the Amplify Console, which makes it extremely easy to set up CI/CD for your static websites and front-end apps. You learned about Lightsail's many built-in OS and application blueprints and saw how quickly we could deploy a LAMP stack to a new virtual private server. And you saw how we used Elastic Beanstalk to set up a monitored, auto-scaling, highly available load-balanced LAMP app in only a few clicks. If you'd like to learn more about any of these services, here are the best places to get started for each. Of course, every situation is different, and you might be wondering about other use cases that I didn't have time to discuss during this session. So it shouldn't surprise you that there are other options available on AWS too. From serverless web apps to various options for data storage and containerized deployments, there are many other services that might be applicable to what you'd like to do for your web app. Here are just a few of my favorites that you might want to look at. And for more information on these, just check out the AWS website. AWS Digital Training offers free on-demand digital courses that help you learn new cloud skills and services when and where it's convenient for you. Register for free AWS Digital Training at aws.training. Let me give you a kind reminder to please complete the survey. Let us know what you thought of today's event and how we can improve the experience for you in the future. Finally, I just want to thank you for taking the time to let me share this session with you. I know your time is valuable, and it means a lot to me that you stayed with me until the end. If you have any questions or comments that you'd like to share about today's session, please get in touch.